Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here today with lesson number 47 in our epic, legendary series of improved Arduino tutorials. I will need you today to pour yourself a nice big mug of iced coffee. I will need you to get out your eLego Super Starter Kit. If you don't have one, look down in the description. There's a link that'll take you to Amazon. 35 bucks, you get the Arduino and all the goodies to go along with it. And it is the hardware I'm using on this series of tutorials. And it does indeed make it easier if we are using identical hardware. In lesson number 46, I gave you a homework assignment, and that homework assignment was to create a bit flipper, where we're starting basically with the circuit that we developed in lesson number 42, which was, I do believe, which was this circuit. You can go to www.toptechboy.com. You can go to Arduino tutorial number 42, and it gives you the circuit. We've got the Arduino hooked up to a 74HC595 serial to parallel converter, and then we're driving 8 LEDs. And in this last series of lessons, we have been talking about the hexadecimal and binary and how to think about those things. And I do believe, if I am not mistaken, that on that lesson 42, that if you go there, or tutorial 42, Arduino tutorial 42, if you go there, I give you some code that is kind of the starting point, that if you have this thing hooked up right, it'll allow you to control those registers through a byte type variable, which is a hex or a binary. If you don't understand, go back and watch lesson number 42. Because the purpose of today is not to redo lesson 42. The purpose today is to make a bit flipper, as you are seeing here. What you see is I write an F0 and it turns it to a 0F. Whatever I write, it then flips it. On bits become off bits, and off bits become on bits. Were you able to do the homework successfully on your own? If you did, leave a comment below saying, I am a bit flipper. And if you say, I am a bit flipper, I know that you did the homework. Sometimes I wonder if there is anyone out there who does the homework, or if you guys just sit and watch me. There are two types of people in the world, those who watch and those who do. And I hope that you are a doer and not just a watcher. So let's talk about how to think about this. All right, I hope you guys figured out an easy way to do it. I realized that you could do it by writing 255 if statements, but I sincerely hope you guys found an easier way to do it. So let's think about this problem, and I think I will use a different pen. Let's think about some cases of bit flipping. So we've got 1 byte, which for the Arduino is 8 bits. So let's say I had 0, 0, 0, 0, 0, 0, 0, 0. You want to turn that into a 1, 1, 1, 1, 1, 1, 1, 1. Okay, all the bits are flipped. If you had a 0, 0, 0, 0, 0, 0, 0, 1, you would want to turn that into a 1, 1, 1, 1, 1, 1, 1, 0. So whatever you have, you want to flip those bits. And I'll tell you, this is really, I wish this camera would show things a little bit clearer, but I am, alas, stuck with the hardware that I have, and so I wish this overhead view was a little bit clearer. Similarly, like if you had 1, 1, 1, 1, 0, 0, 0, 0, you would want to flip those to 0, 0, 0, 0, 1, 1, 1, 1. Do you see a pattern? Okay, if this is, consider this like my byte. Okay, the number that you have is my byte. Do you see that if you have a 1, it becomes a 15? If you have a 0, no, I'm sorry, if you have a 1, it becomes a 255. If you have, I am having trouble stating this correctly. Let me start here. If you have a 0, it becomes a 255. If you have a 1, it becomes a 254. If you have an F0, I'm saying it in binary here, okay, if you have an F0, it becomes a 0F. And so what you can see is simply my byte is equal to 255 or let me put it this way, my byte flipped is equal to 255 minus my byte, right? So all these add up to, this one and this one add up to 255. This one and this one add up to 255. This one and this one add up to 255. So you can flip it by simply subtracting it from 255. Could it possibly be that easy? Okay, we need to go to a code view here. Where is a nice code view? Let's see. What's this one? That is not what I am looking for. You guys don't hate me. Just give me a second to find what I'm looking for. There. That one's pretty good. So we are going to move our circuit back over here. Okay. So we're going to get this dramatic. Do you like this new dramatic view that I'm adding here? I hope so. Let's see. Let's get you a good view there. I actually think that this is pretty cool. I'm going to try to zoom in more just on those LEDs. How about that? Okay. Now, hopefully, oh, that's pretty good. Okay. So now let's go. You see, I think this is pretty cool that you can see the code. And if I get further out of your way, you can see the output from the serial monitor, and you can see what I'm looking at in the circuit. So this is going back to that lesson 42, hopefully. Guys, give me just a second here to get everything up. Okay, so this goes back to that lesson 42, and I'm just going to download that to get the serial monitor clear. Okay, so this goes back to that lesson 42 where you're just setting up your latch pin, your clock pin, and your data pin, and then it's doing the basic control on the LEDs where you basically take your latch pin low. All right, then you send to data pin your data, which we have LED ones, and then you bring your latch pin back high, and then you delay. Well, we don't need to do it twice because we're not switching back and forth. And then up here, I want a better name for my byte, and so I'm only going to use 1 byte, or I'm going to use 2 bytes. Okay, I'm going to have my byte. And so I'm going to call this my byte, type byte, and I'm going to put it in as hexadecimal, so 0x, and let's just try this F0 that we talked about. And then this is going to be my byte flipped. And we're going to declare that, but we are not going to create it because we're going to create it by subtracting my byte from 255, if I am thinking about this right. Then we come down and do our pin modes. And now what we will do is say digital write. We are going to write here my byte, my byte. Okay, so right now, let's just go ahead and download this. And what I should see is I should see coming up on this the F0. Okay, boom, there's F0. Like if I put 0F over here, 0F, and write it, I should see it go to 0F. Okay, so this is just showing that we can take what we are writing here in my byte and we can write it. Okay, now I want to create my byte flip. So after I put that in there, I'm going to say my byte flipped is equal to 255 minus my byte. Does that make sense? And now I'm going to do this right again, all this stuff, where I am outputting it to the most excellent shift register. I forgot, what do we call that thing? That is the 74HC595. And this time, instead of writing my byte, we're going to write my byte flipped. Okay, let's try it. Okay, look at that. I need a little more delay in there. That's kind of going fast. Let's put a second. All right, so it's flipping from 0F to F0. Okay, F0, 0F, F0, 0F. All right, let's do a 0, 1, which would be 0, 0, 0, 0, 0, 0, 0, 1. And that should be kind of interesting. Yeah, that's working. Okay, that's flipping. What if I do a 1, and then over here I do believe I want, what do I want on this one? I got to think. I can't do hexadecimal in my head. Let's say I want let's just do a 1, 1. That should be interesting. Okay. 1, 1. All the bits are flipping. What if I do a 1 and an 8? There it is. Okay, you see that? 1 and 8, and then it flips. So we are able to flip bits here. If you guys were able to do this without any help, let me know. Or let me know if you did it an equally good, different way, or let me know if you did this with some crazy, insane brute force type of approach. Let me see, do we have any homework? I am not coming up with a good homework. It's just we worked so hard on getting this 74HC595 chip working. I just really, I've really enjoyed working with it, and I've also enjoyed kind of getting you to think a little bit more about understanding hexadecimal. Coffee fuels the engineering world. It is the elixir that keeps the engineering world going. And hexadecimal and binary are really the way that you've got to, when you start getting into the nuts and bolts of programming and digital hardware, this binary and hexadecimal is how so much works. And so I hope that through this series of lessons, it's helped you understand it. We'll come back in lesson number 48, and we'll probably be moving on to a new topic. But I would love hearing your comments down below. Would love to get a thumbs up from you. Subscribe to the channel. Click the bell to make sure that you get all of our updates. And think about sharing this with your friends. We need more doers, and we need less watchers. I will talk to you guys later.